Our final lesson in Chapter 1 is 1.7, Linear Inequalities. In Day 1, we'll look at representing solution of linear equalities in one variable, and we'll solve linear inequalities. In Day 2, we'll work with absolute value. We'll start off with a unique way to represent inequality answers using interval notation. Instead of the symbols like less than or greater than, we'll use brackets and parentheses. We would use a bracket in our solution if your answer for x can equal the boundary number as well as be greater than or less than. Therefore, you'll notice you'll have a greater than or less than or equal to symbol, and you use a bracket as that boundary. A parenthesis is used if x cannot equal the boundary number. So you would use a parenthesis if you were given a greater than or a less than. You also use a parenthesis anytime you have an infinity, either negative or positive. Let's put those definitions to the test. Convert each inequality to interval notation. Starting with x is greater than or equal to 3. Now, on a number line, 3 is your only boundary. And if the arrow points to the right, we would have a closed dot, and our arrow would point to the right towards positive infinity. To write it in interval notation, because it's greater than or equal to, we use a bracket where the 3 is. And that means it can equal 3. But as it goes to the right, it's approaching infinity on the right-hand side. And anytime we have infinity, we use a parenthesis. Let's try the next one. Same kind of idea, but now you have a boundary on each side with x. Now we have negative 1 is less than x, which is less than 6. On a number line, you have two boundaries, one at negative 1 and one at 6, always writing from least to greatest. Because of these inequality symbols, we use open circles on our number line. They can't equal the negative 1 or the 6. Since x is in between, we connect them. Using interval notation, negative 1 is your boundary on the left, but it can't equal negative 1. Again, we use that parenthesis. We have a number boundary on the right, which is 6, and we use another parenthesis to represent that. So these brackets and parentheses mean the same as the inequality solutions up above. Let's try that last one. Now x is greater than or equal to 5, but less than 12. So now we have one of each again. Since we have a boundary on the left and the right, on our number line we'll have the same thing. A boundary on the left and a boundary on the right. On that left-hand side, it's going to equal the 5, but on the right-hand side, it's that open circle boundary, and we connect them. If we have two numbers, that means we'll have both of our numbers in our interval solution. If it can equal the 5 on the right, our boundary is that bracket. On the left, on the right, it would be a parenthesis for the 12. So it's a bracket on the left, parenthesis on the right. Down below, we'll go in reverse. The next set of problems actually has interval notation, and we're going to write them just as inequalities with the greater than and less than symbols. For our first example, we have negative infinity on the left and negative 4 on the right. That means the arrow is going to go towards negative infinity, but our boundary on the right is negative 4 with a bracket. On the number line then, negative 4 would be our boundary. Because of the bracket, it's a closed dot. Since negative infinity is on the left, it's going to go towards negative infinity. Ooh, look at how I connected that there. That's pretty cool. To write this then as just an inequality, we know that the value boundary for 4 is equal to, but then everything's less than. That means x is simply less than or equal to negative 4. That would be all the values to the left. The next example has brackets on each side, and we have two number boundaries. So we have a bracket on the left and a bracket on the right. On your number line then, we'll have a boundary on each side. Brackets mean they can equal those boundary locations, and the arrow connects up and over. Because of that, where inequalities, x will be in between 8 and 9, and can equal both of those values. For that last example, I wanted to change it up just a little bit. Would you please create a parenthesis with the 11 where it was originally a bracket? I just wanted to show you, one more scenario that might help us out. For this problem, it says that negative 2 on the left has a bracket which means it can equal -2 on that left-hand side. And we'll use a closed dot to represent that. Now with our modification on the right, the 11 would just be an open circle with that parenthesis, and x would be in between. To write as an inequality, it can equal the -2, but it has to only be less than 11 on the right. And that's just converting from one form of your answer to the other. As we get into solving linear equalities, here are some things to keep in mind. When you solve, you always want to try to keep your variable on the left-hand side if there's just one inequality to work with. When you multiply or divide by a negative number, you're going to flip the direction of the inequality, which will then change the direction on your number line. If you have a compound solution, meaning there's a boundary on each side, always write your answers from least to greatest. We have 3 examples down below. For each of them, we'll solve for x, and then we'll write our answer as an inequality and in interval notation. We'll finally graph our solutions on a number line. For our first example, 5x minus 7 is greater than 3x plus 9. Our rule about keeping the variables on the left-hand side would indicate we should move the 3x to the left, and I'll do that by subtracting. I'm also going to move the -7 to the right by adding. So 2 steps done in one row. On that 9, wow, that should be a 7. Sorry, I knew I meant 7 there. I don't know where that came from. I think I looked over at the 9. That must have been it. I'll put 7 on each side. Sorry about that. So the 7's cancel. 5x minus 3x is 2x. Greater than, on the right, 3x's cancel. 9 plus 2 is 6, or 9 plus 2, 9 plus 7 is 16. To get x by itself, divide both sides by 2. X is greater than 8. That is your inequality answer. Your interval answer means 8 is our boundary, and we'll use a parenthesis. Because the arrow goes to the right, it's going towards positive infinity. Make sure your 8 and your infinity look a little bit different, and there's your interval answer. Now, to create this solution on a number line, all I need is my boundary number of 8. So I'll just pick a spot, put 8. Because of the parenthesis and the greater than symbol, that's an open circle. It goes towards positive infinity, so it goes towards the right. And there's your solution on a number line. Let's try the next one. We have a fraction in this one. 1 minus 3/2 x is greater than or equal to x minus 4. Again, keeping our rule about getting your variable on the left-hand side, I'm going to subtract x here and subtract it here. I'll subtract 1 and subtract 1. But now we end up with negative x minus 3/2 x, greater than or equal to negative 5. If I have a fraction for my x, I need a fraction for my other x and get a common denominator. The common denominator would just be 2. What that means is I'll take negative 1 over 1 and make it negative 2 over 2. And that at least lets us combine like terms. Negative 2 over 2 minus 3 over 2 would be negative 5 over 2. Times x is greater than or equal to negative 5. Now, to get x by itself, we need to multiply by the reciprocal. But notice the reciprocal is negative. The 2 negatives make a positive, the 2's cancel, the 5's cancel. We get x by itself, but because we multiply by that negative, we switch the direction of our inequality. So we flip our inequality. On the right, I'm going to make negative 5 over 1. The 2 negatives cancel, the 5's even cancel, and we have 2 over 1, which equals 2. That is your inequality solution. Now x is by itself, and the 2 is on the right, and it's less than or equal. That means the 2 will have a bracket. But because the arrow goes to the left, it's going to go towards negative infinity. And infinities always get a parenthesis. 2, it can equal, so I'm going to make that a bracket on the right. There's your interval solution. For this answer on a number line, the only boundary number you need is that 2, and it's a closed circle. Because the arrow in the inequality answer points to the left, our arrow on the number line will also point to the left. Let's try the last one. The final problem is an example of a compound inequality. Now we have inequalities on each side of x, which means we're going to keep x in the middle. We need to get everything else away from it. Thinking order of operations, if we have 6x minus 1, the first thing you'd want to do is add 1 to all parts of the inequality, and that moves it out of the middle. On the left, we have negative 3 plus 1, which is negative 2. We have 6x in the middle. On the right, 5 plus 1 is 6. Now to get x by itself, divide both sides by 6. It cancels in the middle. On the left, negative 2 over 6 reduces to negative 1/3. X is in the middle. On the right, 6 divided by itself is positive 1. That is your compound inequality answer, written from least to greatest. Notice the negative 1/3 has a less than or equal to inequality. That means we use a bracket for our boundary on that side. And then it can go all the way up to positive 1 on the right. Since x is only less than 1, we'll use a parenthesis. That's your interval solution. Last but not least, to create that number line, we need a boundary on the left, negative 1/3, a boundary on the right of 1. The negative 1/3 is a closed dot. The 1 is open. Since x was in between in our inequality answer, we connect the two dots, and that's your answer on a number line. There's your lesson for 1.7, Day 1.